Hi there and welcome to a new episode of Playing with Junk. And as usual, it's not really junk, it's something very interesting, something almost new and, in this case, totally working until I take it apart and we will have a look inside. So what is this thing here? It's a SKiiP. It's a Semikron Intelligent Integrated Power Module, or some call it an IGBT. That has nothing to do with sexual orientation. It's an insulated gate bipolar transistor. It has funny contacts, big contacts here for high power, high currents. And then there are a couple of smaller contacts here for the control. What is an IGBT? It's a bipolar transistor with a gate like a MOSFET, so it can be controlled through the gate like a MOSFET, but it has the properties of a bipolar transistor. And they are usually used for high power applications. So we see the whole backside here is a copper plate, or it looks like a copper plate, that goes to a big heatsink. And then the PCB with large contact pads is then just sandwiched together like that with this pressure plate that provides an even distribution of contact pressure here. And there is not much to see here, but it seems it is easy to open, so why don't we try that? And that's the first part out here. You can see it's just some current transformers to measure the current through the contacts. 3 phases, of course. They have these contact springs here that connect to this little PCB here. And then of course, we have a lot of this gooey stuff. Fortunately, it sticks better to itself than to my finger, so it's not a big deal to remove it. And then stick it down to this pile here. And it smells like nothing, and that's good so. I wonder how this stuff is called. If someone knows it, please tell me in the comments. It is a little bit like a silicone rubber, but who knows. Okay, let me clean that part here, which is the more interesting part. Alright, I just destroyed now maybe $300, $400, $500 transistor module. In fact, I couldn't find a datasheet for this model here. It's probably a custom part. The only websites that come up when I type in the part number are websites with spare parts for elevators, lifts, as we call it here. And that makes sense because this module here came from an elevator, from a lift, sorry. At my workplace they repaired one of the lifts and the technicians replaced the entire motor control unit, and this module here was part of that. I thought it's more interesting to take it apart and show it to you guys, because that's not something you see every day. What do we have here? Oops, it's still sticky. The large parts here are diodes. Couple of them. Why? Because all the thin wires here go to one big surface and the other pole goes to the substrate here, to the copper. So that's only a two electrode device. Well, most likely a diode. Then we have the smaller devices here. Those are most likely the IGBTs, the transistors, because you can see there is, for example, one wire going separately. That's probably the gate. And then all the other wires go to two contact points here. And the backside again is connected to the copper. I have another module here, which is a little bit simpler. This is a three-phase full bridge rectifier with 6 diodes. That's this part here. And there is also what they call a brake chopper. So that's a diode and a large IGBT. So you can see there are 2 electrodes here, connected with a couple of wires, but they are all connected together here. So this is collector or emitter. And you also see there is one wire coming in, going to the center here. That's the gate. And there is another diode here. You only see one large contact area with a lot of wires. I mean, we are talking about hundreds of amps, so clearly we need more than one tiny wire here. And that's the other diodes. They always have 2 welding spots on the chip, and then they go down to 1 strip of this copper. And the whole thing here is some kind of ceramic substrate with again copper on the backside. And that's where the heatsink is connected to, with some thermal paste, of course. Yeah. Maybe we can find out a little bit more. Let me take the microscope. There is one more thing to test. This ceramic substrate here should be thermally conductive, very well. Well, let's see if that's the case. So if it is very conductive, the heat will spread evenly across the entire module. And if it's not, then we have one hot edge here and everything else stays cool. Let's see what happens. Okay, that should be enough. Yeah, it's warm here. It's pretty warm here. But it's already distributing the heat. Yeah, I can even feel it here. So yeah, that's a relatively good thermal conductor. So I think it's about the same as if they mounted it on a solid piece of copper, but that's not possible. We need some insulation path between these tracks here. So yeah, that's it. A high power transistor module from a lift. Thanks for watching.